So, what you guys are going to do, you guys are going to use a program, and you're going to have to search for it. This only exists on the laptops, but what you're going to search for is a program called Interactive Physics 2000. Now, these only exist on laptops. They do not exist on the internet. This program only exists on these laptops. And I'll go through all of this tomorrow, but you're going to open up the file, and there's going to be a program that I modified just for this lab. So here's the basic idea, is that you're going to try and land this thing on that landing area right there. But here's the parameters. You can't be going too fast horizontally. You can't be going too fast vertically. If you do, you crash and burn. And that was the concern, even like when they were trying to figure out how to land on the moon. That was the concern, and it was a huge concern. It's like, okay, hey, if this thing is drifting off to the left or to the right, or if it drifts horizontally when it lands, and they're going too fast, and that thing tips over, rut-row, what are you going to do now? Because it isn't like, oh, we'll just call a tow truck and set it back up right. You're toast at that point. So they had to figure out, okay, how fast can this thing be going horizontally when it lands and not tip over? That was one of the things that they had to know. When I wrote this program, here's the story. Anything, velocity, acceleration, displacement, that is to the left or down is a negative value. Anything up and right is a positive value. Okay? Up, right, positive, down, left, negative. So, all you have to do is hit run, and I'll just show you what this looks like here. Go over a little bit. So the left and right controls your side motion.
Yay!
Okay. So, thank you very much. All right, so let me kind of show you what this thing is going to display for you in terms of data. So this is your AX. That's your horizontal acceleration. Here's your VX. So like this one, I had a positive 0.04, which means that I was drifting to the right about 0.04 meters per second. Very slow number. I didn't tip it over. This is my AY, this is my vertical acceleration. Notice that that's a positive number. I landed with a negative velocity. And that's what you have to have, because down is defined as being a negative value. Value of the main thruster, that's the forces coming out of that engine, 9,100. Now, before, you haven't done any calculations, but let me ask you this. That's my applied force. I have a net force that's a positive number. So does this thing weigh more or less than 9,100 newtons? Dylan.
Could you repeat that?
So I've got a positive applied force of 9,100.
Yeah.
I've got a positive acceleration. So does this ship weigh more or less than 9,100 newtons on the moon?
Less.
Less, okay? So that's 9,100. I subtract out what I have to pay to the Gravity Mafia. I got some left over. I have a positive acceleration. Now, down here at the bottom, there's a little cursor, and you can drag that. And when you drag that, you can replay this. So if I move this over, now, notice this. Now, I'm at 8,100 newtons. But now I have negative acceleration. So that means that this ship weighs more than 8,100. Because if I'm only applying an upward force of 8,100 newtons, I get a negative net force and a negative acceleration. So once you do this, you can slide it back and forth, and you could look at how those numbers change. But it's the same thing though. If you look at this, I've got a negative acceleration and a negative velocity. Am I speeding up or slowing down? I'm speeding up, because if you look at where I am on that velocity time graph, I'm right here. I have a negative acceleration with a negative velocity. What am I doing? Speeding up, because I'm going away from 0 meters per second. So here's what you need to have done for tomorrow. So tomorrow you're going to walk in and you need to have the front and back of page 1 done. Just like you are not going to show up to NASA and go, hey, I want to be an astronaut. Let me fly the rocket. And they're going to go, do you understand Newton's laws of motion? Well, no. Guess what? They're not going to let you fly the rocket. So tomorrow, you're going to walk in. I'm going to look over page 1 and page 2. If I find anything wrong with it, I'm going to tell you, hey, you need to fix this. Once that's done, then I'll give you the keys to the laptop. Then you can actually do the simulation and try and land it. Okay, but not until I look over that front and back of page 1. So up here at the top, here are the parameters. G on the moon, negative 1.67 meters per second squared. Mass of lunar command module, 5,000. We're going to assume that that number is going to stay constant. In reality, it's not, because it's going to be burning up some fuel, but for the sake of this lab, that was going to complicate things if I tried to have the mass change. So we're just going to keep that at 5,000. And then anything up and right is positive, anything down and left is negative. So tomorrow, you're going to walk in, you're going to come up one at a time. I'm going to look over this stuff. Pay attention. Sometimes I want you to make free body diagram sketches. None of these are to scale. These are all going to be sketches. Okay? Andrew. Woo! Okay?
Yippee!
All right? Okay, I'm done. That'll be good. So this is what we'll do tomorrow. All right, Andrew, stop your
I
camera.
that they taught how to draw the scale diagram.